All right, welcome to this explainer. Today, we are unpacking something literally bleeding edge, the architecture of DeepSeek Janus-Pro. If you've been tracking the breakneck speed of AI, you already know that multimodal models, the ones that can seamlessly process both text and images, are the absolute frontier right now. But today, we aren't just looking at another incremental update. No, we're looking at a fundamental rethinking of how AI actually understands and generates the visual world. So let's just dive right into the big question. Why do the biggest household name AI models out there still struggle to put objects in the right place or precisely follow complex text prompts? You know exactly what I mean, right? You ask an AI for a highly specific scene, and the general vibe is there. It looks pretty, but the actual details? Completely scrambled. Well, it turns out there is a massive structural bottleneck holding current models back. And understanding that bottleneck is the absolute key to understanding why our topic today is making such massive waves. Here is our roadmap for this explainer. We'll start with the flaws in current AI, then introduce DeepSeek Janus-Pro. After that, we'll break down its three-stage training pipeline, explore the synthetic data advantage, and finally, look at how it's outperforming the state-of-the-art titans.
Section 1, Flaws in Current AI, the status quo. Because hey, before we can appreciate the cure, we've got to diagnose the disease. When we look at current heavyweights, think DALL-E 3 or Stable Diffusion, we see a glaring issue, a massive lack of task decoupling. See, they use these unified encoder architectures that basically forces the exact same internal process to understand an image as it does to generate one, and that creates some serious task conflicts. Throw in a heavy reliance on noisy, inconsistent real-world datasets, computational bottlenecks during training, and really weak object consistency in dense visual scenes, and bam, you get an AI that makes those frustrating mistakes. Are they powerful? Absolutely, but they're structurally conflicted.
Moving on to Section 2, enter DeepSeek Janus-Pro, the disruptive challenger. Now that we see the problem clearly, let's meet the framework that actually fixes it. The magic here boils down to this concept called decoupled visual encoding. Instead of forcing one overwhelmed system to just do everything, Janus-Pro uses a brilliant division of labor. It's like the AI hires a specialized reader whose only job is to deeply understand visual semantics, and a totally separate specialized artist whose only job is to generate coherent pixels. By splitting these tasks up, the model completely sidesteps the performance conflicts that bottleneck everyone else. Think about the direct contrast between these two approaches. The unified old way, like DALL-E 3, uses a single visual encoder. It's constantly compromising, constantly crossing its own internal wires. But the decoupled, Janus-Pro way cleanly separates the tasks. So what's the actual so what for you? Well, it means when you prompt a complex scene, the model actually understands the semantics deeply first, and then generates the image coherently. No crossed wires. Let's pop the hood and look at those decoupled parts. For its reader, or understanding encoder, Janus-Pro uses SIGLIP. This is a high-performance visual encoder that extracts incredibly detailed semantic features. Then, for its artist, the generation encoder, it uses a VQ tokenizer to convert images into discrete IDs, giving you super stable image decoding. And here's where it gets really cool. By feeding these specialized encoders into a single unified autoregressive transformer core, Janus-Pro builds an absolute powerhouse of an engine. It seamlessly concatenates text and image features, letting data flow perfectly for both language and visual tasks. Section 3, the three-stage training pipeline. Because you can have the best engine in the world, but if you don't teach it how to drive, you're going to crash. Let's dive right into this pipeline. We're looking at Stage 1 for initial adaptation, Stage 2 for unified pre-training, and Stage 3 for multimodal fine-tuning. 3 distinct stages that elegantly build from basic feature mapping to complex instruction following. It is a highly deliberate curriculum, completely dodging the chaotic learning processes we've seen in older models. Stage I is all about creating a rock-solid foundation. By extending this initial phase and using ImageNet to map simple, grounded categories, like basically telling the AI, hey, this is a sunflower, learn exactly how these pixels depend on each other, Janus-Pro stabilizes its core. This extended adaptation is absolutely crucial. It completely avoids the early image generation noise that notoriously plagues its competitors. Basically, it learns the basics perfectly before it ever tries to run. Now, consider the exact recipe for Stage 3 fine-tuning. It's an interesting mix. 5 parts multimodal data, 4 parts image to text data, and just 1 part pure text data. This is not random at all. This highly balanced ratio forces the model to prioritize the connection between vision and language. It ensures the AI actually understands intricate real-world contexts, rather than just blindly memorizing text. Which brings us to Section 4, the synthetic data advantage, overcoming real-world noise. Because in the AI space, your model is really only as good as the data it consumes. And here is a massive number to wrap your head around: 72 million. That is the number of synthetic aesthetic samples that were fed directly into this model. Instead of relying purely on scraping the messy, chaotic internet, the creators used advanced prompt engineering to generate 72 million perfect, high-quality examples. This approach drives significantly faster training convergence, and it's exactly what leads to those incredibly vibrant, accurate outputs. This completely highlights why synthetic data is winning out right now. Think about real-world data. It's noisy, it's packed with low-quality samples, and it leads to wildly inconsistent mappings. You might have an image labeled apple that's actually just a blurry photo of some completely different fruit. But synthetic data, generated via robust prompt engineering like Midjourney datasets, it strips out all that real-world noise. The model gets to learn from perfectly dense, highly aesthetic, descriptive prompts, massively elevating its baseline of what good actually looks like. And there's a huge side benefit to this strict data diet. Because Stage 2 focuses exclusively on these high-quality, dense prompts, basically phasing out all the junk data, Janus-Pro reduces computational inefficiencies by 20 to 30%. Let that sink in. By just giving the AI cleaner data, it learns faster, making it remarkably cheaper and faster to train than those heavy, bloated diffusion models. Let's hit Section 5, outperforming soda titans, the benchmark proof. Because architecture and training are great in theory, but how does this thing actually perform against the current state of the art? Well, just look at the absolute dominance of Janus-Pro on the GenEval benchmark, which specifically tests how well a model follows your text instructions. Janus-Pro hits an 80 overall accuracy, completely outclassing SD3 Medium at 74, and leaving DALL-E 3 way behind in the dust at 67. It's definitive proof that this decoupled architecture follows complex text-to-image instructions far, far better than the previous generation. We see the exact same victory when it comes to dense scene understanding. In highly complex scenes where you have multiple objects interacting, DALL-E 3 is really prone to mismatching things, but Janus-Pro scores an 84.19 on the DPG bench, proving it has unparalleled object consistency and spatial understanding. Plus, it scales seamlessly to 7 billion parameters without becoming overly resource-intensive. Honestly, it's just a smarter, far more stable system. But here's the kicker. Because of its massive 90 million sample dataset scaling for a multimodal understanding, Janus-Pro is way more than just a fancy art generator. It's a highly versatile tool. We're talking document understanding, table recognition, chart analysis, data extraction, and even advanced meme comprehension. It's built from the ground up for seamless multimodal dialogue. It actually understands the real world, not just how to paint a pretty picture of it. But perhaps the absolute most incredible takeaway from this entire explainer is this. This state-of-the-art multimodal powerhouse, a model that beats the biggest commercial names on the market, is not hidden behind some corporate paywall. It is entirely open source. The code, the models, the architecture, it's all sitting on GitHub right now for researchers and developers to explore, dissect, and build upon. To conclude our exploration into this disruptive tech, I want to leave you with a final provocative thought. The bottleneck we talked about earlier? It's been removed. The architecture is decoupled, the training is fully optimized, the benchmarks are absolutely shattered, and the keys have been handed directly to you. With this level of unparalleled open source AI at your fingertips, what are you inspired to build next?